Hello, everyone. I'm happy to be here to present our recent work on fuzzing the PHP interpreter via Dataflow Fusion. This is the joint work with Chuqi, Bonan, Jiahao, Manuel, Roland, and Zhenkai. The PHP is one of the most popular web engines in the world. It powers over 70% of the websites globally, and it used the extensive C code base, like over 1 million of lines of code, which presents a significant attack surface. However, existing PHP researchers only focus on application-level security, for example, like SQL injection. Memory corruption bugs in C, most common cause the critical vulnerabilities, are overlooked. Here are two CVEs in recent years that caused by memory errors. So the research question is how to improve the low-level security of the PHP ecosystem. Fuzzing is a well-known effective approach to discover bugs. It generates a diversity of inputs and drives software into unexpected states. The challenge of fuzzing is how to automatically generate diverse inputs. There are two methods of fuzzing. One is mutation-based input generation, which starts from a corpus of existing inputs and produces variants by applying random and guided mutations to those seeds. And another method is grammar-based input generation, which uses a formal grammar of the input language to generate syntactically valid input from scratch. Let's use the figure to represent these two fuzzing methods. And there are some common weaknesses in such methods. The first one is the limited semantic diversity, even though they could have high syntax correctness. Additionally, they are also very hard to reach deep logics when fuzzing compilers like Clang or interpreters like PHP. So the research question is how to generate inputs with diverse code semantics. The mutation-based fuzzing mutates one input at one time. Then we think, can we take two or more inputs at one time and do further transformations? So here we introduce the input fusion. It's a new fuzzing method based on the two or more seeds and fusion. What could be the effective way to merge inputs with diverse semantics? One naive solution is to do seed concatenation. However, it makes no big difference from executing them separately. Let's recall seed selection. Usually, the corpus are a collection of known proof of concepts from bug reports, unit tests, etc. And they are minimized code snippet to test one single feature or bug reproduction. So, seeds are typically unit-level program snippets designed to test a single functionality or regression in the code base. They usually, for example, over 90% in PHP, execute sequentially. That means without branches. This implies that control flow has minimal impact on their code semantics. Thus, we think Dataflow could be a very good representation of the code semantics of PHP program. The definition of data flow means how values move from their points of definition to their points of use. Then the seed fusion problem becomes the data flow fusion problem. Let's take the concrete example to show how do we do the data flow fusion given two PHP programs. Here is one PHP program that has the code semantics of base 64 encoding, and we extract three variables and list their data flows. And this is another PHP program, and we do the similar things. Given two data flows, we can have such data flow fusion option. So we connect the last variable in the test case A to the second variable in the test case B. And in this way, we can have such fused program as the fuzzy input. And you can see now we have a new test case to fuzz the DOM operation on base 64 object. Let's try to have another data flow fusion option. In this way, you can see we connect the second variable in the test case A to the last variable in test case B. So random data flow combinations can create variant code semantics. And we can also reverse the order of test cases. Let's put the test case B in the head and connect the data flows from test case B to test case A. And in this way, you can see such data flow fusion can trigger a 20-year-old memory error existed in the PHP interpreter. Let's take a look at the Flow Fusion overview. Flow Fusion collects PHP files as corpus and execute inputs in the PHP engine for fuzzing. And we also have the recursive fusion mechanism. When the fuse input can have the new coverage or find new bugs, we can add them back to the corpus. And such recursive fusion enables more complex semantic fusion among when we have more than two seed programs. We have the fuzzing setup as we continuously fuzzing the nightly build of PHP interpreters for 6 months. And our oracle is the address sanitizer and undefined behavior sanitizer, as well as the direct crashes and assertion failures. We also have multiple complementary strategies. The first one is the test mutations. So before fusion, Flow Fusion applies some mutations to original test cases. It introduced semantic variations while maintaining syntactic validity. And the example is we will do some operators exchange or we assign some special values. Another strategy is interface fuzzing. For example, after generating fused test cases, Flow Fusion will inject random function calls to the internal APIs. And we will reuse variables from the fuse context as the arguments for these function calls. This can effectively test the robustness of the internal APIs. Finally, we have the environment crossover. So we not only merge the PHP programs, but also their configurations. We will also randomly introduce other valid configurations collected from the entire test suite. And here are some examples. For example, we will adjust the memory limits. We can adjust the G settings and OB cache modes. Then let's move on to the evaluation. I would like to first present our bug results. So from the paper, we have the key findings of detected 158 unique bugs and unknown bugs. Our bug reports has led to the security improvements across more than 80 source files, and the related patches have modified more than 5,000 lines of code in the PHP source code. And here's the bug breakdown. We can see most of the reported bugs have been fixed or confirmed. And we have covered multiple CWE categories, including step buffer overflow, heap buffer overflow, buffer underwrite, user free, etc. Let's take a look at the comparison to existing works. Here is some baselines. The first baseline is the PHP internal test suite. It is maintained by PHP developers for CI/CD testing. Another well-known fuzzer is AFL++, which adds advanced instrumentation, consistent fuzzing, and customizable feedback for faster vulnerability discovery. And another related work is Polyglot, which is a multi-language fuzzer that translates inputs into uniform IR, applies constrained semantic preserving mutations with semantic validation. So our evaluation setup is we will count the code coverage after 20 hours of fuzzing. And here is the result. We first take a look at the official test suite, which achieved the 78% of the coverage, which is higher than the AFL++ and Polyglot, surprisingly. So based on the official test suite, we evaluate our FlowFusion tool. We can see that FlowFusion tool has improved the code coverage for around 3% after 24 hours fuzzing. FlowFusion has continued impacts. FlowFusion is a living project which incorporates nightly builds in PHP source code to test the new features. And you can also get auto updates when new test cases are added into official test suites. FlowFusion also has community integration because it becomes the official toolchain for its outstanding bug discovery effectiveness, and it helps developers to improve PHP interpreter security. Here is our monthly bug report count. We can see that FlowFusion's impact is not stopped by the paper submission or acceptance. It focuses on the sustained community support. And we will continuously find, detect new PHP memory errors nearly every week and keep reporting our bugs to help PHP interpreter better. Here is the summary of this work. We propose a novel fuzzing method called fusion-based fuzzing, which takes two or more seeds from the corpus and merge their code semantics. Our tool, FlowFusion, is available, and you can also check this link for our recent bug reports. Here are some future works we might explore. For example, we can introduce more test oracle to detect other bug categories that FlowFusion missed. And we are also happy to adapt this method to other programming language implementations like CPython or JavaScript. Additionally, we can also combine with a language model to have more smart seed combination of fusion. Thank you.